Back up for effect.
Ooh. All right. So chapter 3, section 3 is what we're looking at today. And we're going to start with this postulate 15. Corresponding angles postulate. All right? So if I'm writing this on a proof, if someone asks a question, what if it's a theorem that doesn't have a cool name, right? Well, in that one, in that case there, you're going to have to write down the theorem. Like theorem 3.1, 3.2? Those just said 3.1, 3.2, and 3.3, right? But most of them have names. And most of the ones that you're going to end up using in your proofs, you're going to be able to use the ones with the names, okay? So for this particular one here, the postulate 15, what we would list on a proof would be this is the corresponding angles postulate, all right? Again, I love to use abbreviations, love to use symbols, especially when I've got a 4x6 note card that I'm trying to cram as much in on as possible, right? So I'm totally cool with you putting something like COOR angle, something like that. I'm okay with you just doing that on a test as long as there's no question that this is corresponding, right? If you give me enough of the abbreviation for me to know that. But at the very least, on your note card, I would sort of abbreviate this stuff. Make sure you know what the abbreviations mean, but just in order to save space, I would do something like that. And so what this postulate says, we could write out the definition, but to me, a lot of these are really easier to make sense of if you just draw a picture, right? So I've drawn a picture. I've drawn two arrows here to signify that these lines are what? Parallel, right? And then I've drawn a transversal right here, a line that goes across both of those, and when I do that, it's going to form an angle here, and it's going to form an angle here. And what this postulate 15 says is that angle 1 then has to be congruent to angle 2. So these are what we call corresponding angles, right? We've learned that definition previously. This postulate tells us that those angles are going to be congruent. So again, how you write this down on your paper, totally up to you. You just need to understand what it means. It's also easier to kind of read if you don't have a lot of wordy stuff. So pictures are great when you're looking at your little cheat sheet, your note card, whatever you want to call it. So we've got some bunch of theorems here that they list as well. So let's go ahead and list those and just draw some pictures to make sure you understand what those mean. There's a theorem that is the alternate interior angles theorem. And we could actually use our same little diagram here. So that might be something that you want to do on your note card to save space, right? I can just put a different number right here. We've got two parallel lines again, cut by a transversal. And what this tells us is that the alternate interior angles, the angles that are on the inside of the two parallel lines but are on alternating sides of the transversal, that those angles are congruent. And so I could write this as angle 3 is congruent to angle 2. If you think it's confusing and you want to write that as two separate diagrams, that's totally up to you. But that's one way to sort of save space, right? Theorem 3.5 is the consecutive interior angles theorem. And this says, and I'm going to add another number on there. This says that the measure of angle 4 plus the measure of angle 2 has got to equal 180 degrees. So those angles are supplementary, is what that says. Consecutive interior angles are supplementary. We translate to mean that the measures equal 180. right, theorem 3.6, just moving along. Alternate exterior angles. We've only got one exterior angle right now drawn on our diagram. Which one is an exterior angle?
One.
One. I've heard both of you ladies answer something so. So I could say I'm sort of drawing these out of order. It doesn't really matter. But in my diagram here, your diagram could look totally different from mine. But what that tells me in this diagram is that angle 1 is congruent to angle 5. So alternate exterior angles are congruent. So let me, I'm going to write down here are congruent, and are congruent. So I've got a quick notation there for what the theorem states, but then, and I would actually probably take this stuff here, right? I would say, I would write that angle 3 is congruent with angle 2 outside that, so I know it goes with that one. I would write this one actually down here. And this one here would have the measure of angle 4 plus the measure of angle 2 equals 180. And then finally, one more. And this one we're going to have to draw a new picture for, so I'm going to do it over here. We can't use our existing diagram, theorem 3.7. Perpendicular transversal. All right, and that says we got two lines. I don't know what it says in the book, but I've done it. It's H and K in line. I draw this one transversal, which I've labeled as J. And so it just basically says if J is perpendicular to H, then J is perpendicular to K. So that's the gist of the theorem. So any questions about those? They're just kind of stating those facts, right? But now these are facts that we can use to prove, to complete our proofs when we're trying to prove things. But is anyone confused about the definitions of the theorems or postulates? So like the first thing that they ask us to do in the examples, just so we can practice writing some proofs out, is they say they want us to prove the alternate interior angles theorem. So this one here. And they tell us that we have a drawing here, looks like this, that they show us these are parallel. And we've got this transversal over here, and we've got 1, 2, 3, like that. And then it's given that P is parallel, that this must be P and Q. P is parallel to Q. And so they want us to prove the alternate interior angles theorem, which is this guy here. And so based on that, they want us to prove that angle 1 and angle 2 are congruent. Angle 1 is congruent to angle 2. And so we have our statements. reasons. And so like I said, when you're proving these things, you got to explicitly state why you can jump from one statement to the next. So this first one is given. P is parallel to Q. And so they're asking us to prove this one, so we can't use this one for our proof, but we can use what we've learned before that. And one of the things we learned before that is this guy here, right? So we know based on postulate 15, the corresponding angles postulate, we know what? Based on our diagram and based on that postulate there, what can we say is true?
3 is corresponding to 5.
Well, this is our diagram that we're using for this one.
Oh, sorry.
Right? That's okay. It's kind of confusing the way I've got it all drawn out here on the board, right? So what did you say?
That would be 1 is congruent to 3.
1 is congruent to 3. So this angle here is congruent to this angle. Does everybody agree with that? Those are corresponding angles, right? So if I were to give you this proof and I left this blank right here, it should be obvious based on this drawing here. The only angles that we've got that are corresponding angles are 1 and 3, right? Angle 1 is congruent with angle 3. Okay? So we know that that's true. How does that kind of help us? You know, we're trying to get down here to this idea that angle 1 is congruent to angle 2. So how is this fact going to help us with that? Well, we can see that we know that there's a relationship between angle 3 and angle 2. And what is that relationship? Yes, Cal?
Because the vertical angles postulate they're congruent.
They're congruent, right? Is it a postulate or a theorem? I think it's a theorem, isn't it? Yeah. Vertical angles, theorem. If you call that a postulate, I'm not gonna count off unless I'm hungry. If I'm hungry, I might count off some points, but I'm probably not going to count off for that. But if you've got a cheat sheet, you should know, right? That's something that you should write down. It's a postulate versus a theorem. So yeah, you're right. That tells us that angle 3 is congruent with angle 2, right? And so if I know that angle 1 is congruent to angle 3, and that angle 3 is congruent to angle 2, then I can say that angle 1 is congruent to angle 2. And what is it that tells us we can kind of go down that path there? If one angle is congruent with another, and then that angle is congruent with another, then I can say that the first angle is congruent to the last one. Transitive, right? It's the transitive property. Transitive property of angle congruency or something like that? Of congruence. Yeah. Transitive property of congruence, right? So, and realistically, if you put transitive property on there, I'm probably going to give you credit for that, right? Because again, unless I'm hungry,
so even
or someone's drinking an iced coffee in front of me and didn't bring me one, something like that, that could upset me.
So even on a test, you'd accept transitive?
Yeah, just transitive property.
Oh,
Yep.
okay.
Yep. Okay. But if you've got it written down, you know which one it is right now in the folder.
Right.
All right. Any questions about that? How we kind of put those pieces together and did that proof? You see how you kind of have to break it down and tackle, and kind of you find some logical path to go down. Like I said, if I'm giving you one of these, I'm going to be like giving you pieces of it and leaving the blanks in there. But you have to know enough about what's going on to be able to fill in the right blanks appropriately, right? Okay. So these are the ones that I like to do more, and I really should have put all of my definitions kind of on the side so we could reference them. That would have been helpful. But let's go to example 2, using the properties of parallel lines. And so, given that the measure of angle 5, let me just draw this picture here. they label some angles 6, 7, 5, 9, 8. And they tell us that angle 5 is 65 degrees. So I'm going to label this guy here. This one here is 65 degrees. And so find, I'm going to turn my notes are good. Okay, so I can see what I'm looking at. Find each measure, tell which postulate or theorem you use. So the measure of angle 6. And try to do this without looking at the book, all right? Because this will help you. Don't focus so much on trying to get your name on the board. Sometimes that backfires on me and doesn't accomplish what I'm hoping it will accomplish. But try to just look at it and figure it out, because that's going to help you as you're reasoning through this when you're doing the problems on your own. What do we know about angle 6 if we know the measure of angle 5?
It's a vertical angle, so it's the same.
65 degrees.
It's what? What did you say?
65 degrees.
It's 65 degrees also, right? So, and I think I heard you, Camille, say that it's the which theorem?
It's a vertical angle.
The vertical angles theorem, right? So I know that the measure of angle 6 then has to equal 65 degrees, right? We started with the fact that the measure of angle 5 equals 65 degrees. And so we know this is true by the vertical angles theorem, right? The next one they ask us about is the measure of angle 7. So let me write that down. And do I know anything about angle 7, either by the angle of the measurement of angle 5 or angle 6? So let's let someone who's not on the board yet. You're like, oh man, he always does that to me. But just to see if anybody else knows, what can we say about angle 7 now that we know angle 5 and or angle 6?
It's a supplement with 6.
It's a supplement. How do you know that it's a supplement?
Because it's on the same 180 degree.
Right, but it forms something. What does it form?
When you match it with 6, it forms 180 degrees.
It does. David, do you know what I'm asking for?
It's a linear pair.
A linear pair, right? So you see how I'm trying to get you to think about, I've got a postulate or a theorem somewhere that's got this in it, and it's this the linear pair, and I don't even remember. Is it the postulate or the theorem? I don't know. Is it the postulate? Okay, the linear pair postulate says that these two angles here, or I could say these two angles here, I can pick either one, they have to total up to be 180 degrees, right? So measure of angle 7 equals 180 minus 65. And so that's 115. 115 degrees, and so that's the linear pair postulate. So I had Jackson and Mr. Waternoose. That's great. All right, so let's see, Ian, you had your hand up back there for that one, didn't you?
Yeah.
All right, so I'm going to ask you the next one. All right, are you ready for this?
No, he's not.
All right, let's see, measure. You're like, I didn't want this one.
Yes, I better be ready.
Measure of angle 8. All right, so this angle here. And now this is one of the new ones that we learned. So based on the new ones that we learned, what can I say about the measure of angle 8 compared to one of these angles that I already know now?
It's the same as 5.
It's the same as 5, right? Equals the measure of angle 5, which is 65 degrees. And how do I know that?
Because they're corresponding.
They're corresponding angles. So that is the corresponding, that was the first one that's on the back side here. Is it corresponding angles postulate? Is that what we call that?
Yes, sir.
So the corresponding angles postulate tells us that. Corresponding angles postulate. I knew you could do it, Ian. Nice job. And then last of all, measure of angle 9. So we've got some different ways we can tackle this one. Actually, now that we know the measure of angle 8, we could go back to our linear pair postulate and figure it out that way, right? But is there any new theorem that we've learned that will help us figure out 8 where we can just say, boom, I know what 8 is because of this?
Alternate exterior.
Alternate interior, did you say?
Exterior, was it?
Alternate exterior, right? So theorem 3.6, who said that? Paul? Theorem 3.6 says that alternate exterior angles are what?
Right.
They're congruent. And so what's the alternate exterior angle to 9?
7.
Measure of angle 7, that's right. So these are equal to one another, and so they both have to be equal to 115. So alternate exterior angles theorem. Very good. All right, nice job, guys. So you see how you have to put these pieces together? And so I could give you a problem like that and say, give me these measurements, or I could say, hey, give me a proof, right, that kind of like we went through all these steps here to prove to me that maybe 9 and 7 are equal to one another. Okay, another thing that I could do is do like what they've done in example 4, where we have, they draw a picture and they say find x. And so this particular one looks like this. Those are not very parallel lines, like that. It's because I don't have any iced coffee for Chick-fil-A. So we've got something that looks like this, 125 degrees. This is angle 4, and this is x plus 15. And so the problem says, use the properties of parallel lines to find the value of x. And by the way, that may be useful too as you're starting to label all this stuff and you're building your data that you're going to eventually build, one page that you can use on like a semester exam or something. You may want to label like certain theorems. These were all related to parallel lines. So you may want to kind of label it like that. So if you see a problem that has to do with parallel lines, you know that I'm zeroing in on that section of my cheat sheet. All right? That doesn't sound like a nice name, right? My supplemental materials sheet.
Helpful paper.
That's right, my helpful paper. All right, so we're solving for x here. So what do we know based on the theorems that we learned today? What can we say is true about how can we use the information that's given here to solve for x?
Do the corresponding angles.
And this looks like, this is actually just, that's the angle 4, but we don't know what angle 4 is, and they're asking us to find. It's not 4 degrees, I just want to make sure you know that. So what did you say, David? Oh, wait a minute, we got some hands in the back. Does anybody that has not answered yet, do they want to say something? Something relevant to the problem. So, David, you said something.
That was not me. It was actually me.
Oh, it was Aiden. Okay. It was Aiden. Hey, 2 of your letters in your name are the same. Okay, it's okay. So, Aiden, you said what theorem or postulate?
The corresponding angles.
Corresponding angles will tell us that this angle has to be equal to which angle? 4, or congruent, I should say, to that angle. So we know then that this guy is also 125 degrees. And then by the
Linear pair postulate.
by the linear pair postulate, we know then that what? What does that tell us? What does that tell us, Ian? Since you were given the
Yeah. If you add them together, they'll equal 180.
That's right, exactly. So if we know that if we add 125 to x plus 15, that whole thing's going to equal 180, right? So we're going to combine our like terms on this side. We can just drop the parentheses because they don't do anything for us in this case. So 125 plus 15, that's 140, plus x equals 180. We subtract the 140 from both sides, and we get that x is equal to 40. Everybody see that? And we can plug that in just to make sure. 40 plus 15 is 55. And does 55 plus 25 equal 180?
Yes, sir.
In this side of the universe, it does. That's right. All right. So let's move on to the next chapter. Proving lines are parallel. So this is interesting. Now we're going to see a bunch of postulates and theorems that are sort of the reverse of what we just looked at. All right. In fact, they're going to have similar names, but they're going to add converse to the end of it. Are converses still popular, or have they kind of that is that in recent times.
Still
They're still popular. Okay.
They're pretty relevant, kind of.
It's funny, they were popular when I was a kid, right? And then they got like dirt cheap because nobody wanted them, and now they've come back and they're popular again. I'm like, I can't believe how much people are paying for a pair of Converses. I mean, that was a couple of years ago when I saw that. Maybe they've come down again now, but yeah, it's all about supply and demand. It's just funny, and then it repeats itself. All right, so the corresponding angles converse. This is postulate. What did it say? 16. Corresponding. Can I just abbreviate that? Save some space here. Corresponding angles. Converse? Is that what they call
You
it?
could draw a shoe for the shorthand.
What's that?
You could draw a shoe for the shorthand.
That's right. I like it. But I always did the high top one, so I gotta kind of bring it up here. And then we gotta put the star right there. All right, so the corresponding angles, yes, just converse. Corresponding angles converse. And so that says that, let's see, am I going to be able to all right, so if I've got a drawing like this, and I've got another line like this, and I know that these two angles here are equal to one another, right? And if I draw a little curve in here and I only draw a single curve, I don't draw two of those, then I know these angles are the same. So that's the symbol that tells you those angles are the same. If I were to give you a drawing like this, that would be part of the given, right? That these two angles are the same. It's given by the drawing. And so we know, because these two angles are the same, that tells us that angle J is parallel to angle K. And so it's kind of reversed. Before, we knew they were parallel, and so that told us that the two angles were congruent with one another. But now we're told the two angles are congruent with one another, and so because of that, we know that the line's parallel, right? So, two line. I'm going to write this one out just to make sure. It's a little harder to see just by the drawing. Are cut by a transversal. Plus, this will make sure that you're getting the different names, like transversal, that you know what that means. I'm going to label this line L here. So, which line is the transversal in that drawing? L is the transversal, right? L is the transversal in this. So make sure you know what a transversal is. It's a line that crosses two other lines. And the lines don't necessarily have to be parallel, right? If we have a line like this and a line like this, as long as I've got a line that runs across like this line is the transversal. It intersects both of them. So if two lines are cut by a transversal and corresponding angles are congruent, the two lines are parallel. And Ella, because you're in my class, every time I draw parallel lines now, I think of Ella. I'm gonna slip up and say that one day. The two lines are Ella. That should be your symbol right there. Yeah. Do you guys remember Prince? And the musician Prince, and then he decided he wasn't Prince anymore. It's like, I'm just known by this symbol.
Oh, yeah.
Really?
And it didn't even work.
And so then they had to say, what's that?
Prince.
Yeah, everybody had to say the artist formerly known as Prince. Too funny. Not funny at all. It probably explains why we have some of the other junk going on now that we've got going on. Like why people can say, no, call me by this. I'm just supposed to accept that. All right, anyway, we're getting off topic. So does that make sense how this is the reverse of what we had before? Right? So what about theorem 3.9? Consecutive interior angles converse. Again, we've got a converse here. So before we had, did they do these out of order in the book?
Mr. Walker, did I miss on my notes that we did the alternate interior angles?
Did we not do that?
I don't have them in my notes.
Did I not do 3.4?
I had that.
You mean 3.8?
Well, I'm talking about the first one. You're talking about the first one, the alternate interior angles?
The alternate interior
I-
angle
wait.
converse is just 3.8.
Yeah, I just skipped that one.
We did.
I just skipped that
3.4.
one, right? So I thought you were talking about from the previous section. I did alternate interior angles in the previous one, right?
Yes, sir.
Yeah, okay, so I'm jumping ahead here. And this actually was this way in my notes, so that's my bad. So let's change this to alternate.
Because I just thought I missed it in my notes.
Yeah, no. That was my bad. So alternate interior angles converse. Alternate interior angles converse. Okay. So for this one here, again, it's the reverse of everything that we had on the last one, right? You've got a drawing. You've got these alternate interior angles, 2 and 1. And if, I'm just going to write this down like this. If measure of angle 1 plus the measure of angle 2 equals 180 degrees, then J is parallel to K. And so you label this as J and that is K. So that's basically what the theorem says, right? So does everybody get how these are just the reverse of what we saw before? On all of these, right? Before, we knew the lines were parallel, so that means these angles had to add up to 180 degrees. Now we're told the angles add up to 180 degrees, so then that tells us that the lines are parallel. And so for time's sake, I don't think I'm going to write all the other ones down, because they're just the reverse, but I want to make sure that everybody's getting that, right? Theorem 3.9. 3.9, that's the alternate. No, it's not. It's the consecutive. My notes are messing me up again. Consecutive interior angles converse, right? We could say here, we could add 3 here if we wanted to, and we could say this and this, and if angle 3 is congruent to angle 1, J is parallel to K. That's basically what that says. And I might as well write it down since it's already this far along. Alternate exterior.
Wait, isn't the... Did you mix up the I guess the explanation of alternate interior angles and consecutive interior angles?
Alternate interior. I did. I'm sorry. Alternate interior angles. Man, you guys forgive me. It's a good thing that Cameron is here today. So yes, this goes here. This goes here, right? So this is about consecutive interior angles. 1 and 2 have to add up to 180 degrees. So let's do what I did before. Then we'll make this 3.9, and this is 3.8. All right, and we're going to say this is alternate. No, this is consecutive.
Yes, sir.
Interior angles, and this is alternate interior. So that's probably the easiest way for me to fix that. And you just make sure that your notes are. Sorry about that. I'm going to write the alternate exterior angles converse here, which says, so we're going to draw angle 4 out here and 5 out here. So we've got alternate exterior, and that says if angle 4 is congruent with angle 5, then J and K are parallel. All right, does that make sense? Sorry if I confused you guys. It was totally on purpose. I mean, accidentally.
Wait a minute.
All right, so let's do some examples and just make sure that we can apply those theorems. And
Those 1980s films. Just like
that's what they're talking about.
bad. No, it just sounds like just the bad quality audio. It's like from Up.
Very well.
Charles ones.
All right, so just to look at one of the examples in the book. It does. You're right. Adventure is out there. All right. I can totally hear that now. All right. All right. So here's my question for you. If I gave you this drawing here, are J and K parallel?
We can't assume that, but
You
I guess we
cannot
have
assume that, right? Even if it looks like they're drawn that way. Just like if I do something like this. Right? And I say, this is, I just say this is X. You can't assume that X is 90 degrees. I would have to give you something else to prove that, right? I'd have to give you I'd have to draw a little square here like this. Or in order for you to know these are parallel, I'd have to put little arrows on both of those in the middle of the line, okay? So get in the habit of recognizing that, because that's kind of the trick part of some of this stuff, right? It's like you look at it and you may assume something because the drawing looks that way, but I didn't actually explicitly state it in the drawing, okay? So what this particular problem here says is it says find the value of X, and if they just said that, we would be in trouble. So we don't have any way of figuring out the value of X just if they just said that. But they say find the value of X that makes J and K parallel. Right now, we've got something to work with. So if J and K are parallel, what do we know about the relationship between X and 4X? Yes? They're supplementary. Those two angles here are supplementary, right? So that means that X plus 4X has to equal what? 180, right? Did someone whose name was not on the board say 180 just then? Gabe? Okay. I almost called you out on purpose, and I was like, well, I don't want to embarrass him in case he doesn't know. But yes, you're right, 180. So who else can I call out and embarrass? Grace has, I really want to embarrass Grace. She's already got a mark against her today, so I'm playing, I'm not embarrassed. Maybe. So X plus 4X, we just combine like terms, right? And then we divide both sides by 5, and so we get 30. Does that make sense? I can't hear anything but up now that you've said that. Thanks.
You're welcome. I think the answer is not 30.
It reminds me of the
5. What?
It'd be 80 minus 50 is 30, so.
Oh, what did I do wrong? X plus 5X. What now? Oh, I'm sorry. Yeah. 30 is if it would be
150.
if it was 150, right? So again, I was testing you guys. You passed, David. So what is it?
36.
36. Yeah, we got to add another 30 to it. Thank you. It's because I'm going through the Up movie in my mind now. I'm hearing this
Singing
background.
Home Alone when he's watching the TV.
Yeah.
Home Alone in what part?
When he
He's
watches
watching the TV and he's like using that to get the bad
Christmas
guys.
is filthy animal.
Yeah.
And a
that
Happy
one.
New Year.
Oh, okay. Oh, that part. I got you. Yeah. All right. Let's see. Let's use. I'm just kind of picking some examples out here. How are we doing on time? We're doing pretty good, actually. Did we get done at 2? I mean, 2? I just looked at the clock. I'm like, whoa. It's because they haven't changed their clocks yet. All right.
2 o'clock.
So let's do example 5. How about that? Decide which rays are parallel. So example 5 says, oh, so they are watching something. I was like, it sounds like they're. It doesn't sound like Mr. Lewis. All right. I was like, he's got his own soundtrack. Cool. It's a whole laugh track. You know, I want that. My own laugh track. That would actually be hilarious. When I put the videos online, I'll put some whole laugh track behind it. It's like, I love my wife here. Look, the kids love me. Listen, everything I say, they just think it's hilarious.
Laugh track.
All right, 59 degrees, 58 and 62. All right. And so we're deciding which rays are parallel. And so we're asked the question if whether or not ray EB is EB. And again, try to do this without looking at what they're doing in there. You're like, I've already done it. Too late. Is EB parallel to HD? So this ray here, is this ray here parallel to this ray here? They're not.
Because of the angle.
The angle degree.
Because this angle here, if they were parallel to one another, if these right here were parallel, so think about this, recognize that when you're looking at this, what we're seeing is, if we kind of extended, did a little dotted line back out here, right? Now, this looks like all of our theorems and the postulates that we look at, right? We've got two lines that we're not sure if they're parallel or not, but we've got these two lines here, and they're cut by this transversal, EH, or EG, or whatever you want to call it. And so if these lines are indeed parallel, then you're right. This angle here would have to be congruent to this angle here, and it's not, right? So is EB parallel to HD? No. Because 58 degrees does not equal 61 degrees. Those would have to be the same. I guess they give us, yeah, I guess that would be the better way to do it. They give us actual, because HEB, angle HEB, is not congruent. How do you do that? Can you do that like that? I'm not sure. Angle GHD. Right? Because these are not congruent to one another. All right, what about EA? Is EA parallel to HC? Parallel to HC. All right, so for this one here, we don't have two angles here so that we can compare them together, right? So that's a little bit harder.
Well, we just have to do some math.
We just have to do some math. And since this is a math class,
Makes sense.
it makes perfect sense. Yeah. So what is the math that we're going to have to do?
Well, since it's a straight angle,
Can we find this? Yeah.
and you just need to add up 58 and 62, and take 180 minus that, which would be.
Yeah, right. So did you guys follow what she said? She recognized this is a straight angle, right? We don't have only two angles, so we can't say it's a linear pair. But this is a straight angle, which equals 180 degrees. This whole thing here, right, is 180 on both sides, and that's straight. It's a straight angle on both sides. So we know then that this angle here, they don't give us a point over there? Huh. I'm surprised they don't give us a point out here so that we could call it something. I'm going to give us a point right here. So we're going to, what do we not have? A, B, C, D, E, F, G, H, I.
Is there an F?
There's not an F, is there? Is there not? I don't think
I
there
don't
is.
think so.
I really know the alphabet. I don't have to sing the song. All right, so we know the angle F, E, A. Does everybody see that's this angle here? That has to equal 180 minus 62 minus 58. Everybody follow that? All right, so when we add all that up, 62 and 58 is 120, right? Did I do the math right that time, or are you going to call me out on that one as well? Did I get it right here? You got that one right? Okay. So 60 degrees is what that angle is equal to. So we could write a 60 right here. All right? We can find the angle here the same way, right? So we know that angle EHC has got to equal 180 minus 59 minus 61. And that turns out to be the same thing. So this is 60 degrees as well. And so, based on that, then we can say that angle A, now what was the question? This here. Ray EA, which is our line that kind of goes on back here, and this is our line that goes on back here. These are parallel. Yes?
Yes, sir.
Because angle FEA is congruent with angle EHC. Oh, and they did it differently. I didn't think about that, right? We could have just looked at this as one big angle right here, and just recognized that this big angle here is 120, and this big angle here is also
That makes
120.
sense.
Right?
That's a little easier.
So there's always more than one way to skin that cat, right? And did I offend anybody by the skin the cat statement? I hope I did it because I'm not a cat person.
Dogs are way better.
Truth.
But I'm not a cat person, but I love Chinese, so
Oh yes.
skin that cat.
I don't
How does that? Wait, what?
That was always the joke growing up. You know, it's like there were all these cats hanging out around the Chinese restaurant. You know, so you go in there and eat the chicken, and it's like this chicken has a weird consistency. I just don't know. But hey, it tastes good. All right, so have we been through everything? Did I say I was trying to get through? What did we start with today?
Don't know.
0.3.
3.3. Yeah. So let's do one more. All right.
3.5.
Let's do. Oh yeah. Right.
We have
Because we're having fun today.
We have 20 minutes.
Wait, does that mean we have less questions for each lesson, or this, or
You sound
study
exactly
three?
like our pre-calculus class. That's funny. You guys are funny. Oh man, you guys crack me up. So there, we got a problem like we had before, right? There's no description here given. We just have a theorem.
Gasp.
So theorem 3.11 says this. If you got parallel lines here. Like this, P, Q, and R. I actually had a traumatic experience with a cat. That's why I had this kind of cat. Issue. A cat ate my dog, and I never. I'm joking.
It's like a lion or something.
All right, then. So if P is parallel to Q and Q is parallel to R, then what can we say about P and R?
They're
They are-
parallel.
They have to be parallel, right? So that's what this theorem says. Duh.
Couldn't that be the transitive property of parallel lines?
Yeah, I wouldn't mind them calling it that, but they don't do that.
So is the theorem universally known as like this one 3.11,
That's a good question.
or is it just for this book?
I kind of figure it's just for this book. you
That's
know,
what I was thinking.
That
Well,
they just
it's not a
organized under this
theorem.
book that way. So yeah, if you go to college, they may not accept that. Right?
They're like,
I wouldn't go to college after finding that out. It's dangerous. All right, so let's see. I really should quit recording these lectures. You know, somebody's going to come back to bite me. It's gonna be, Mr. Walker told my child not to go to college.
Disclaimer.
Joe.
Go to
All right, so similarly, if ilm is perpendicular to P and N is perpendicular to P, then ilm must be parallel to N, right? So that's theorem 3.12. Oh, and then this other one, you guys have seen this before. This is just the definition of slope. I feel like we've talked about that in here already, haven't we?
Yeah, in the algebra review.
Yeah, okay. So slope is just to make sure that you remember the definition of slope. Slope can be thought of as rise over run,
Where we see that?
right? And so you just need to know that for doing some of the problems in here. I think I've got it written down in this section, so hopefully I'm not giving you useless information. But just to make sure, and maybe it's for one of the other sections, but just make sure that you remember. Let me make sure it's not 3.6. It's designated as 3.5 in my notes, but that's actually the next one. So never mind. You don't have to probably think about slope yet.
Good.
That's 3.6. All right. So yeah, again, these are straightforward enough that I don't think we need to spend a lot of time kind of going over this. And they just have a couple of quick examples, mainly proofs. So let's do one proof. Well, it's actually the proof for the theorem. So they have one of those ugly proofs on page
Oh, that one.
page number 158. Yeah. What do we call those? Flow proofs?
Yeah,
right?
I think that's.
So it's a flow proof.
That's scary.
Yeah.
I don't understand.
I haven't asked you guys any of those. And as long as you understand how they relate to the two column proofs, I'm not that concerned about that. Does everybody understand how flow proofs relate to two column proofs? Yeah?
It's kind of taking two different things that you're doing and then combining them with a central thing at the end. I just find this two columns a bit easier to follow.
It's a lot easier to follow. To me, the flow ones are a little more complicated, and it's easier for you to get yourself in trouble when you're kind of drawing the flow ones, right? When I'm saying trouble, I mean like run out of room on your paper. It's like, I wasn't planning on having another section over here, right? And all these guys converging together. So it's a little bizarre. But let's just see if we can think through this one and make sure that we understand it. So does everybody have the book so that you can look at this one with me, and we'll just kind of talk through it, and that'll be the last thing we do today.
What page is it?
I'm on page 158.
Thank you.
Yep. So we're building a CD rack. And kids these days, they're like, what's a CD?
Circle.
We live in a day of online music, right? Digital music. So which CD is digital music. It's just
Old digital.
part coded on the CD. So you're building a CD rack. You cut the sides, bottom, and top so that each corner is composed of two 45-degree angles, right? So we've got this box that this piece of furniture that we've made, and we've got these 45-degree angles up top there. And they just kind of note that this is angle 1, and this is angle 2, and those are equal to one another because they're 45 degrees. And prove that the top and bottom front edges of the CD rack are parallel. So they also labeled this 3 and 4 down here, 3 and 4. And so what's given to us is that angle 1, angle 2, angle 3, and angle 4 all equal 45 degrees, right? The measure of those angles, I should have said, sorry. Measure, 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 measure. There we go. There's little ilms if you can't see it on the back row. That's why you should never sit on the back row. You can't see my little ilms up here. Yes?
Technically, a CD is a cylinder, not a circle. Very thin.
It's true.
cylinder.
It's got a little bit of thickness to it, so you're right. Yeah.
Tiny bit.
Right. That's a great point.
So that would mean a paper circle is also a cylinder.
That's right. It's got a little bit of
Technically-
thickness to it, right?
So is there
Yes.
such thing as
It's an actual circle.
circle?
that's not like.
I mean, it can't have any width to it, right? So
Hmm.
theoretically, can we create an actual circle?
Unless it's like
Only if it's
digitally.
just on a flat surface.
2D object or whatever it's called on a paper or something.
Yeah, I mean, it's like, it's,
That would be a circle.
even on paper, like even if I put, if I draw ink on here, well, that ink's gonna have a little bit of height to it if I could measure it finely enough, so, right, it then becomes,
or on a screen. Maybe a screen.
Yeah, that's what I was
maybe.
thinking.
That's true.
Okay.
Screen could have an angle.
Wow.
I literally.
Man, I'm glad we had this conversation.
Right?
This is,
actually-
this is so useful.
You're
All right.
welcome.
Well, thank you, yes. So what we're proving, let's see, that we've got some labels here, A, B, C, D. So A, B, C, D. And so what we're trying to prove is that BA is parallel to CD. Prove BA is parallel to CD. All right. And so as you walk through the proof here, let's just talk through it and make sure we understand all the pieces. All right. We're given the fact they kind of split it up, right? And they deal with angle 3 and 4 since they're connected together out here. And angle 1 and 2, they deal with those separately from one another, right? And so we're given, how do we do it on time? People make me nervous when I start seeing people out in the hall. Measure of angle 1, let's just see if I can write it down real quick here. So measure of angle 1 equals 45. Measure of angle 2 equals 45 degrees. And we got a little box for that, and that's just given to us. And then over here, we've got the measure of angle 3 and the measure of angle 4. Both of those equal 45 degrees. And that's given to us as well. And so the measure of angle ABC, that's got to equal the two of those together. You guys agree with that? This angle here has got to be 1 and 2 added to one another, right? So the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. You see how nothing's really understood? I mean, you can't just assume, you have to explicitly state that. So measure of angle BCD is going to be equal to the measure of angle 3 plus the measure of angle 4. And what tells us that? How do we know that is so? Turns out there's a postulate called the angle addition postulate.
Whoa.
Do you guys even remember learning that?
Yes.
Yeah.
Maybe. I don't. So it's. I'm sure it's in there. This is why you need to put that down on your note card, right? Because we forget what these things are called. We just kind of we learn the principles, but we don't remember the name behind the principle. So we combine these together. Since that is the case, then I can say that the measure of angle ABC is equal to 90 degrees. Right? And again, I can't just say that. I have to prove that I'm allowed to do that. And I'm allowed to do that because I know that by substitution I can plug in 45 degrees for both of these, and then 45 plus 45 is going to equal 90. And so it's the substitution property that lets me do that. Same thing here. Measure of angle BCD equals 90 degrees by the substitution property. All right. Now, we were talking about this with the quiz. Because of that, that means that angle ABC is a right angle. And it means that angle BCD is a right angle. And I know that because of the definition of a right angle. There's got to be a reason for everything that I write down. Definition of right angle. I think it's right on my pants. You guys with me?
Oh, yeah.
Yeah. All right. So that means that BA and BC have to be parallel lines. Segment BA has to be parallel to segment BC. I'm running out of room here, so I'm going to kind of do this tightly. And that segment CB is perpendicular to CD. Again, that is because of the definition of perpendicular lines. Definition of perpendicular lines. We're almost done. You guys following this? Mm-hmm. All right.
Oh my goodness.
Do you see how easy it would be to miss a step somewhere, though? Because you just assume, that it's okay for me to jump from here down to here. If measure of angle ABC is 90 degrees, well then can I just immediately, right? I just said ABC is 90 degrees, so can I just jump directly from that down to the definition of perpendicular lines? But what we have with the definition of perpendicular lines has to do with right angles, not with the measurement of 90 degrees. And so that's why we have that little piece of information in there. So we get to our last step where we finally can prove then that BA is parallel to CD. Line segment B is parallel to CD. I think I forgot to write that here. And that is because in a plane, two lines perpendicular to the same line are parallel. Now, where did that come from?
The I.
We're playing 2.
Huh?
Plane 2.
Plane 2? Say that again?
I don't know.
Well, we're proving in a plane two lines that are perpendicular to the same line are parallel. Where did we get that? I don't remember learning that. Did we learn that somewhere?
Theorem 3.12.
Theorem 3.12, but that's what we're proving, right?
Oh, okay.
Well, it doesn't say explicitly prove that, but yeah, Theorem 3.12 says that, although it does say in a plane. Okay, I missed that when I wrote that down. All right, so I'm not going to write all that down. I'm just going to say Theorem 3.12. So this is important. I'm okay with you just writing that down on your test. All right, and so this right here, because they wrote that down and didn't write down Theorem 3.12, did something fall? That leads me to believe that these theorem numbers are not standard across the board. Right? That's why they spelled it out instead of writing the theorem number down. Okay? Make sense? You guys followed all that? Yeah? You guys could repeat that to me if I just erased it and said, all right, tell me and walk you through. Yeah, Ella, certainly. Okay, good. Next week, quiz. We're going to have a quiz. It's going to go through section 3.5, like we just did. But here's what I'm going to do. I'm going to focus more on you guys finding the measurements of angles or finding the value of x versus having to do like all this proof stuff. Okay, so I more want you to understand what the definitions mean this time. That's what I'm going to quiz you on. Does that make sense? Cool.